Okay, so in this video we're going to have a look at an ordinary level question involving addition, division and modulus equations in complex numbers. So we see we're given z1, z2, they remind us that I squared is equal to minus 1, and they give us the equation for z3. So we want to find the value of z3, plot and label the 3 points. So they tell us z1 is equal to minus 1 plus 3i, and z1 bar is what we call the conjugate. So you change the sign of the imaginary part, and that will give me minus 1 minus 3i. z2 is equal to 2 minus 4i. Change your sign of the imaginary part, and we'll get 2 plus 4i. So it's z1 plus your conjugate of z2, which is minus 1 minus 3i plus 2 plus 4i. We'll rewrite so it's like with like. That's minus 1 plus 2 minus 3i plus 4i, which gives me 1 plus 1i for z3. Here's my answer, and now I'm going to plot it on my graph. 1 plus 1i will sit here. z1 was minus 1 plus 3i sits there, and z2 was 2 minus 4i. And that's my 3 points plotted. So z3, z1, and z2. And we've answered part A now. Part B, we're asked to prove that the modulus of z2 is greater than the modulus of z1. So a formula not in our log tables that we need to memorize is that the modulus of a complex number is equal to the square root of a squared plus b squared. So write down what we know. z1 is equal to minus 1 plus 3i, and z2 is equal to 2 minus 4i. So my modulus of z1, there's a and b, again a and b, is equal to minus 1 squared plus 3 squared. So that's 1 plus 9, which is equal to root 10. And for z2, we get the square root of 2 squared plus minus 4 squared. So that's 4 plus 16, which is equal to root 20. And we get root 20 is greater than root 10. And we just give back a statement. Okay, and that's part B. So down now to part C. And they tell us that James writes down the following. Do we agree and justify our answer? So again, we'll write down what we have. z1 is minus 1 plus 3i. z2 is 2 minus 4i. And z3 is 1 plus 1i. Or we can write it as just 1 plus I. Okay, so z1 plus z2 is equal to minus 1 plus 3i plus 2 minus 4i. So that's minus 1 plus 2 plus 3i minus 4i, which is equal to 1 minus 1i. So my modulus of z1 plus z2, here's a, b, is the square root of 1 squared plus minus 1 squared, 1 plus 1, which is root 2. And for z3, my a and b values are 1 and 1. So it's the root of 1 plus 1, which will give me root 2. So So you have root 2 equals root 2. And here we can say I do not agree, and we'll give them an explanation as the modulus of z1 plus z2 equals the modulus of z3. Okay, and our last question now involves division. Z1 is equal to minus 1 plus 3i, and Z3 is equal to 1 plus 1i. Okay, and we're being asked to divide. So it's 1 plus 1i over minus 1 plus 3i. And always when we're asked to divide complex numbers, we multiply by the denominator's conjugate. So our denominator is z1 and the conjugate is minus 1 minus 3i. And our rule as always is if I multiply the bottom, then I need to multiply the top also. So that'll be multiplied by minus 1 minus 3i over minus 1 minus 3i. So that's 1 times. And it's just easiest here to split the brackets. So we get minus 1 minus 3i minus I minus 3i squared all over 1 plus 0i minus 9i squared. So from part 1 they told us I squared equals minus 1. Top line tallies up to minus 1 minus 4i minus 3 times minus 1 all over 1 minus 9 times minus 1. So that's minus 1 minus 4i plus 3 all over 1 plus 9, which will tidy up to 3 minus 1 gives me 2 minus 4i all over 1 and 9 is 10. That's 2 over 10 minus 4 over 10i into your calculator, which will tidy up to a fifth minus 2/5 I. So Z3 divided by Z1 is equal to a fifth minus 2 over 5 times I. And that's that question answered.